The last example is an easy one to get the answer right for on a multiple choice question, a little bit harder on an essay question because the answer in terms of explanation is a little bit more complicated. You're going to increase the pressure of the system by adding helium gas. Now I realize in your assignment in the booklet it simply said pressure increased, and I've added the phrase when HE helium gas is added. So if you could do the same, that would be great. So we're adding helium gas, which means there's more gas in the container. So yes, the pressure goes up. However, again, remember Dalton's law. Dalton's law from grade 11 chemistry. Pressure total in a mixture of gases is equal to the pressure of one gas plus the pressure of another gas plus etc. So in this situation we would have pressure of SO3 gas plus pressure of O2 gas plus pressure of SO2 gas, and now we have a fourth gas, pressure of helium. So the total pressure goes up, increases, but the pressure of the SO3, pressure of the O2, and pressure of the SO2 don't change. Okay, so for example, if the pressure before adding helium had been 1 atmosphere, and we added, say, another atmosphere of pressure of helium gas, then Dalton's law says the total pressure would now be 2 atmospheres. The original 1 atmosphere plus the extra 1 atmosphere of helium would now be 2 atmospheres. But notice that the pressure went up because of the extra 1 atmosphere. The original pressure, 1 atmosphere of SO3, O2, and SO2, doesn't change. So we don't actually change the partial pressures of any of the gases that were there. Therefore, since we're not changing their pressures, no shift in equilibrium occurs. The O2 is unchanged. Okay? Now, another way to possibly remember this is that you're adding helium gas, and helium's not in the reaction. So in a multiple choice kind of question, that's how many students will remember this. That's not a great way, though, to think about it, because there are times when you add a gas and that gas or that substance reacts with something in the container. When it reacts with something in the container, it can change the concentration of that substance, and that will cause a shift in equilibrium. Here, helium, of course, is a noble gas and therefore doesn't react with anything in the container. Noble gases like helium and neon and argon are inert gases. They don't react with other things. Okay? The best answer here, though, is the one that we've given below. The total pressure increases when you add a noble gas like helium, but none of the pressures of the gases that were there initially changed. Therefore, no shift in equilibrium occurs. Notice if we had changed the pressure in some other way, like, for example, decreasing the container's volume. So if we had decreased the container's volume, the pressure inside would go up. It would go up because the pressures of each of the gases increased. So that's why changing the container's volume does cause a shift in equilibrium. The pressures of each gas are changed when the container's volume changes. But adding an extra gas like helium doesn't change any of the pressures that were there initially. It just adds an extra gas and changes the total pressure. So adding helium doesn't affect the equilibrium position. I hope that helps. We'll do a couple more examples in class of Le Chatelier's principle. This is a really important topic for your test on both the multiple choice and long answer sections and on your final exam.